In this short video, we're going to apply using nth roots to real-life situations. In this first example, it says the population P of a certain animal species after T years can be modeled by P equals C times 2.72 raised to the negative T over third power, where C is the initial population. Find the population after 2 years if the initial population was 1,000. So they give us some information that we're going to have to plug into the formula. We want to find P. We do know that our initial population is 1,000, and that is our C value. So we know C is going to be 1,000, and we also know we want to have the population after 2 years. So that tells me my T value. So if I substitute those in the formula, I'm going to get 1,000 times 2.72 raised to the power negative 2 over 3. And there you can see we have our third root, and we have that rational exponent. So in order to do this, I would just use my calculator and plug everything in exactly as you see it. So if we were to type what we have into our calculator, we're going to have to put in 1,000, and then it was times 2.72, and then we have to raise that to the negative 2/3 power. Now, I don't want to just do negative 2/3. I need to make sure that the calculator knows that the entire exponent is negative 2/3. So I'm going to go ahead and insert, I'm going to hit second, delete, and insert a parentheses, a left-hand parentheses around the exponent and a right hand to close it off. So if I hit enter, we should have the population. So this is kind of a sad situation because it looks like, oops, it's kind of a sad situation because it appears that the population is decreasing, and it started at 1,000, and 2 years later it's only at 513 if we were to actually round to the just nearest whole number. So we have 513 species left. And that's something we'll talk about when we have that negative exponent, that this base value will decrease over time. Let's do another example. In this example, a men's shot put, which is a metal sphere used in track and field, has a volume of about 905 cubic centimeters. Find the radius of the shot. Hint, we're going to use the formula the volume equals 4/3 pi r cubed for the volume of a sphere. Well, we know our volume is supposed to be 905, so I'm just going to substitute 905 in for V into our formula. So we'll have 905 equals 4/3 pi times the radius cubed. Now I want to solve for my radius. That means first I have to isolate it and get rid of that 4/3. Now instead of dividing by 4/3, I'm going to do the inverse operation and multiply by the reciprocal negative 3/4 to both sides. If you do that, the 4/3 and 3/4 cancel, and on the right side of the equation we'll just have pi times r cubed. Now what we have to do now is multiply 905 by 3/4, and if you do that, you're going to end up with 678.75, and now I'm going to divide both sides by pi. And what's going to happen is I'm going to have that the radius raised to the third power is 678.75. All of that's over pi. Now, we learned how to solve for r by taking the nth root. Since it's being raised to the third, I'm going to want to take the third root. So I'm going to raise both sides to the 1/3 power to take the third root. So if I do that, I will have r. So in my calculator, I'm going to have to type in 678.75 over pi, all of that raised to the 1/3 power. I'm going to show you how I would do that to get the best answer for this problem. Let's pause this. Now unfortunately, every time I bring up this calculator and I exit the drawing mode of my video, I lose what I wrote down. So hopefully you have that written down. Of course, you can rewind right to see what was written down. But now what I want to do is type in my calculator that final expression, which was in parentheses the 678.75, which I want to divide by pi. Now your calculator does have a pi button on it, and I think you have to hit the second and the caret symbol, which is under clear. So if you do that and close the parentheses, that's the quotient I want, 678.75 divided by pi. Now I want to raise that entire quantity to the 1/3 power, which I'm going to write as a rational exponent, 1/3. And make sure you have that in parentheses. Now this will give me the most precise answer. You can see I get about 6, even if I round to the nearest hundredth or even thousandth, I'll get 6.0, and I think the units on the original volume were centimeters. So let's go ahead and make sure we write down our answer. So we have our radius is about 6 centimeters for a shot put. I think what's left is a couple of problems for you guys to try. So what I'd like you to try now is the self-quiz. You have one volume problem, which is very similar to the one we just solved for the shot put, and then you also have one that has to do with about how many reptile and amphibian species an island can support. So go ahead and try to answer those, and we'll see how we do tomorrow in class. Thanks for watching.